Welcome everyone. As usual, as I say, good morning, good afternoon, good evening, wherever you're dialing in from. Today's session for our virtual thought leadership series, where we talk about how do we should reflect our strategy, how we should recalibrate going forward so that we could rebound as quickly as possible. Because while we're still kind of going through this unprecedented situation with COVID, at the same time, there are a lot of opportunities, especially into Industry 4.0 and critical infrastructure we could address with emerging technologies like IoT, AI, and so on and so forth. So today we have got wonderful three experts from different locations and different organizations. First with me on this platform is Volker. He's the head of Asia Pacific for Festo, based out of Thailand. So thanks, Volker. Then we have Mark. He is a COO for Biqmind, based out of Singapore. And then last but not the least, we have Anil Sravat, who is the CEO for Wabag, Thailand. And obviously myself, CK, founder CEO of AllThingsConnected Singapore. AllThingsConnected is a digital transformation and IoT strategy company based out of Singapore. We focus on Southeast Asia. We look at the entire value chain into the IoT. As you know, IoT is way more complex than three letters. We look at end-to-end approach from strategy to how we drive the total ecosystem value with our partners to solve the problems of the customers as well as the partners. We have certain vertical focus, manufacturing, obviously. Then we also address built environment, mobility, and transportation. We work both sides of the partners, ecosystem, and users, working with them on their digital strategy, IoT, Industry 4.0 strategy as extended team. At the same time, we do quite extensive work with the solution partners, whether they are unique startups or large mid-sized companies or the corporate, could be from anywhere in the world. Again, I'll not go through this too much detail. Basically, our goal is, and that's what we also advocate to our solutions partners also, that IoT is not about box selling or platform selling or connectivity selling. It's about solution selling, and it have to have a business outcome. It's not something we can do it alone. We have to have a hand-holding journey with our partners to drive and close the gaps for the customers. This is our standard framework. Sound simple, but multi-layer, multi-tech and multi-phases, basically where we work with the customer to discover what they want to do, all the way to help them to remain sustainable and scale and look ahead. In the process, we address a lot of non-technical issues like change management, organization behavior, ROI, how we should understand the investment of Industry 4.0. Does it make sense for them or not? What are the priorities should be taken care before we talk about Industry 4.0, which is pretty big buzzword, which is our framework called Digital Strategy, Organizational Strategy Framework, pretty practical and very straightforward, because just one part of the framework, if I can share here, as I mentioned, Industry 4.0, very big topic. Depend on the complexity level, depend on the readiness level of the organization in terms of the knowledge. We can talk about complex thing, but if we don't bring the knowledge together in terms of the complexity, we won't be able to address it. So whether is the use case is category 1 solution, category 5 solution, we need to address it differently. So quickly about these sessions, right? Why we have been hosting this session? Because there are thousands of webinars happening. AllThingsConnected, as I mentioned, work closely with the customers as well as technology partners. So our purpose of hosting these discussions are to help our partners and customers and largely the ecosystem of Industry 4.0 to drive knowledge, network, and collaboration, because no matter how big we become, we can't do it alone. And I'm sure most of the speakers will also agree with that. So we've been hosting sessions for last several months virtually. We've been hosting sessions physically for last 4-5 years. This is just a virtual report for last 4 months. We have hosted about 54 global experts for different topics, different verticals, different regions, different cities. And we have been receiving very positive feedback, and hence we are going to continue hosting such sessions. So some of you who might have missed our previous sessions, you can always go to YouTube to watch some of them. Just search AllThingsConnected on YouTube to get to our channel, and we can see how we discuss some of the topics like healthcare, even ethics on AI. We had last week's session. Very good feedback. So lastly, if you are doing something interesting and you would like to partner with us to share some of the work which you do, or the technology which you are innovating, please reach out to us.
Thank you, CK, and thank you for the opportunity to speak today. And as you say, good morning, good afternoon, and good evening to all the participants who are joining us today. In regards to the area that I would like to run through is looking at the Industry 4.0 capabilities in and around harsh and hazardous environments. This is one area that's sometimes overlooked in what is possible to do and what needs to be done for these types of environments. As I start, I'll just give you a quick introduction about myself and the Biqmind as a company. Myself, I started as a software engineer a number of years ago, moving into product development and IT strategy and IT operations. A lot of the verticals that I've worked in have spanned across aerospace, oil and gas, smart buildings, smart cities, consumer technology, and also telecommunications. So a lot of the learnings that I've taken over the years have come from various types of industries and various types of verticals. In regards to Biqmind, sorry, it's just taking a second to update. Sorry, 2 seconds. There we go. So in regards to Biqmind, Biqmind itself, we provide specialist services and software products in the area of cloud native computing. Just a short definition for those for cloud native, for those that are not aware of what cloud native actually means. For the last number of years, we've obviously had a shift of going towards cloud computing, which typically was moving current and legacy applications from data centers into cloud providers. However, now the move is towards cloud native computing, which is where we're developing software and tools and solutions specifically designed around the cloud. So this term of cloud native is specifically looking at how software is developed for cloud and how we can take advantage of the cloud when it's natively created for those types of environments. So Biqmind itself specifically focuses in that area of cloud native computing, and we do that in 3 areas. The first of those is through a form of discovery workshops where we work with clients on very focused programs and very short focused programs, 1 to 3 days, in defining goals, use cases, and action plans that can start them on their journey of cloud native. And these are typically either technology focused or actually industry focused. We also augment that with specialist services where with clients, we provide advisory and implementation services looking at bridging the gaps around cloud native process, product development, and technologies. And typically those areas are with software architecture, software development, DevOps, and project management, specifically around cloud native development for software. The final area is our product side of the business, where we are developing tools and software for the cloud native world. A lot of the cloud native technologies that are in use today are born out of open source technologies. And those technologies, although it is great and of great benefit coming from the open source world, for enterprises and industry to actually use them, they need to be supported through enterprise tooling to provide the level of backup that you would expect for your industry and for your enterprise. So we have developed a number of cloud native tools, the first of those being CAPE that we're bringing to market, specifically around cloud native Kubernetes development. Coming to the actual topic that I'd like to discuss today, the challenges around Industry 4.0 solutions in harsh and hazardous environments. And one of the reasons that we look at this is because a lot of the technology that's being delivered into those environments have to be specifically designed to meet those environments. And when I talk about harsh and hazardous environments, typically we're looking at the start of the supply chain within the manufacturing processes. So this is typically looking at petrochemical, oil and gas, pipelines, mills and mines and so on. So the early stages of the manufacturing supply chain that we're looking. And these environments, when we look at a lot of Industry 4.0 solutions today, a lot of them are driven towards the further up the manufacturing chain. So I'd like to specifically look at the harsh and hazardous, the early parts of it, and the types of technology or the types of work that you need to do to look for Industry 4.0 solutions. The first thing around these is the actual difference between harsh and hazardous and how we look at them. In regards to technologies that's delivered for these environments, on the harsh side, when we look at the actual hardware that needs to be utilized for solutions in these environments, they have to cope with very extreme and challenging conditions, whether that's wide operating temperature, high humidity, corrosion, shock and vibration. So it's not realistic to take solutions and hardware off the shelf that's designed for other environments and then use them in these types of harsh environments. They just can't cope. On the other side of that, when we look at the hazardous, which is coming into sort of mining, oil and gas and so on, petrochemical, pharmaceutical, it's more about the hazardous conditions for the workforce that is working in these environments. The equipment that then and the technology that has to go into those environments needs to be able to be certified and regulated so that they don't cause any problems within those hazardous environments for the safety of the workforce that's there as well. So the harsh side of it looks at the actual how the technology is built and how it can cope, and the hazardous side looks at the certification and the regulations to ensure the safety of the workforce in those environments. To give you an idea, I'd like to just run you through a practical application that we built as Biqmind. We built for a company called Lantern Edge, which was a positioning solution that they were looking to develop and deliver to the oil and gas industry. Primarily it was for the oil and gas industry, but it's not exclusive to that industry. There are a lot of industries with similar requirements and similar needs. The first of these considerations that we had to look at was from an environment consideration of that particular industry for oil and gas. They are highly regulated, as I'm sure you can imagine, due to the nature of the products that they're working with and the materials that they're working with. And we have to look at designing equipment and technology that is certified and regulated for these. So looking at how we design equipment that doesn't generate spark or hot surfaces, there's no electric static discharges, and this is a very heavy restraint on the type of technology that we can use for those environments. And this goes to actually then having...
Click on play.
Yeah, they started.
You're in.
Anil, sorry to interrupt, Mark. Let me mute Mark. Anil.
No problem. Sorry. So these type of considerations then have a very big factor on the type of solutions that you can use in this type of market. For a solution like positioning, where we're all used to using our mobile phone for GPS and so on, these type of environments, you can't use mobile phones, so the luxury of having GPS and positioning in that form isn't available to this type of industry. So these are some of the considerations that we need to look at when we're designing for Industry 4.0. The challenge that we had in regards to this is obviously the harsh natural environment of oil and gas, especially on the exploration and drilling side, but also that hazardous environment. There's also requirements in these types of industry where musters and safety drills have to be executed once a month so that the workforce is kept safe. So a lot of regulation is put on to ensure that the safety of that workforce. There are existing solutions that are available in the market for that type of thing, but typically they're very expensive, they're complicated, and they're only single point solutions. And the other areas of challenges that we hit is low and unreliability connectivity. If you can imagine an oil rig offshore, it's going to have very low bandwidth and very restricted bandwidth. So the advantages of using the cloud and so on are also a challenge. So you can't just solely deliver for the cloud connected. The actual solution that was delivered for that industry, the requirement side of it is on the exploration side, it's temporary solutions. So we have to be able to build for temporary or permanent solutions. We have to reduce the amount of cabling, which means that we have to look at as much wireless technology as possible. And the range of customers and range of sites that we typically, this solution would work for, ranges from tens of workforce up to thousands. So it needs to be able to deal with that. And the goals of the actual solution was, in the event of a disaster, the positioning solution can be there to aid first response times and improve those so that emergency services can be rendered, thus ensuring as much worker safety as possible. In regards to, from a productivity side, there's a direct correlation from solutions like this towards areas like muster or headcount drills, where typically a manual muster drill may take 2 hours to 4 hours to execute, and during that time, production is stopped. There is no production going on, which is a direct correlation to revenue. So by utilizing solutions and new technology solutions where we can automate those muster and headcount drills, we reduce the amount of time that the drills are taken down to 30 minutes or 45 minutes, thus allowing the shutdown to be much quicker and having a direct impact on the revenue from that side. The actual solution is built up of a number of devices that Biqmind delivered to Lantern Edge, from wearable devices, mesh networking technology. Also from a perspective of these sites and this type of industry has a very poor connectivity options. So the computing has to be done at the operations. It has to be done close to where it is actually needed. So we needed to provide computing power into the actual operation. And when your operations are very rugged, harsh, very unforgiving towards computing, finding ideal computing equipment to cope with those environments is very, very difficult, which is one of the reasons that Lantern Edge looked at designing their own to deliver that computing at the edge. This is also then bolstered with the software to actually allow the users to utilize the solution for their needs. The actual mesh networking and positioning technology, the mesh network is built up of a number of devices that can cope in these harsh environments, and other devices that are regulated to be actually in the hazardous zones and certified under global regulations like ATEX or IECX. Those devices provide the positioning data of the workers within the site or within the environment, which is then processed locally at the edge of operations, but also allowing for the connectivity to centralized cloud for multiple site management. Thus, enterprises and industries that have multiple sites are able to see in one overall view. The final part, a lot of what I've discussed has been around the hardware and the technology needing to cope in these types of harsh and hazardous environments. When you're delivering technology solutions for Industry 4.0, the hardware itself needs to be able to cope in those harsh and hazardous environments. The other side of it is then the software. we've had over the last number of years a very large swing towards cloud computing, and there's been huge benefit in commercial, in business, in industry to that cloud computing. But the reality is that not every application or not every solution can be delivered from cloud computing. It's a very distributed environment. Whether it's running from a cloud provider, whether it's running from an on-prem data center, or whether it's actually needed to run at the edge of operations. So there's a very distributed environment that software and that solution needs to run in. And what has happened over the last number of years, software development has moved towards this cloud native development mindset, which is sometimes making the assumption that cloud is always available, but the reality is not there. The reality is that it is very much a distributed and hybrid nature for the software to run. So when we look at the software that we need to develop to meet Industry 4.0, we need to look at how we can deliver those solutions from a software perspective into very distributed environments, whether it be running at large scale within the cloud and utilizing the scalability of cloud, or running on-prem for security reasons, or running edge solutions for quicker decision-making within the operations. So from that, hopefully that was a little bit enlightening of the type of work that's required for running Industry 4.0 technology in harsh and hazardous environments. And I'd like to hand back to CK and say thank you.
Thank you very much, CK. I will not go towards the topic of harsh and hazardous environments right now. I will keep it more general because we have done this journey over the past couple of 4 years. We have set up a reference plant in Germany, which we call Industry 4.0 ready, first steps towards Industry 4.0. But to implement a full Industry 4.0 environment, I'm convinced it will take another maybe decade, if not longer. So what we wanted to do, what we want to start in Germany is, of course, a fully automated and flexible production facility from lot size 1 to mass products. We want to have a flexible flowing production. Also a lot of cost saving topics when it comes to material flow. And of course, a big portion of cost saving is also optimizing the energy consumption, which we are doing quite professionally. And last but not least, this will also a major part of the presentation today is without training people further, an Industry 4.0 implementation may go fatally wrong. So let me start a little bit with the challenges we are facing. I mean, first of all, of course, we need to address all the new IT challenges. We need to change our digital core in order to reach an efficient production. And of course, we also need to think of smarter products. And this is how our digitalization framework looks like internally. I will not go into details because it's quite comprehensive and quite detailed. If I may use another picture, this most likely shows how complex an Industry 4.0 implementation may be for, let's call it a mid-size company. We are not a super large company, but we are quite a big mid-size company. And this is how we see the implementation of Industry 4.0. And later on, when I talk about training, when I talk about qualification, I may pick out a few of those words. But the first question normally what we ask is how much do people really understand about ERP, MES systems, and so on? Do they really know the difference? Do companies really know whether the right tool for them would be ERP or the right tool for them would be MES? So also here we need to really start training the people, training the companies to make the right decisions into the right applications at a certain period of time. So we started first of all to look in our digital gap, and there is actually a lot. Whether we look into the shop floor, whether we look into customer interfaces, we are facing a lot of digital gaps, and they are still prevailing here and there. I mean, shop floor is not fully integrated. We have a lot of isolated systems. We have a lot of older equipment, which is also not ready to be implemented. And to give you a little bit of some details, I mean, on our shop floor, we are still using more than 40 different IT tools. And I think this shows already a big challenge when it comes to digitalization and implementation. And I think we are not the only ones. If I'm not wrong, also some good friends of mine from Bosch are in the call. And I'm pretty sure they can confirm that also they are having this kind of tremendous issue. So first of all, closing the digital gap needs to be addressed, of course, from the top floor to the shop floor or vice versa, data flow from the shop floor, from the machine level up to our ERP system. What we also did is, and this is where we invested a lot of time, for example, is we digitized our manual assembly processes. I'm also not going into further details. However, here you see a few technical support tools like a glove cam, a barcode reader, assisting all those kind of movements. And what may go totally wrong is if people do not really consider how to digitalize, for example, the assembly instructions. It is a huge effort, and this is normally underestimated. It's a huge effort to digitalize this. And just imagine one instruction goes wrong, you won't be able to come out with a proper product. And this is why you need to keep in mind that whenever you apply digital to a broken thing, you will end up having a digital broken thing. And this is also now coming up a lot when we talk about digital twins, when we talk about more simulation tools, applied simulation tools. Whenever the reality may not work, of course, digital is also not working properly. And this is the underestimation that a lot of companies do not consider. And this is another part whereby we really need to train and skill our people further. So here are some examples. For example, when we talk about this assembly support system, here we are using our SAP Manufacturing Execution Suite. This is our overall overarching MES as well. Of course, as I said, here and there, we are still using a lot of more tools because it is currently not able to reduce the amount of IT tools to just a couple or a handful of tools. What we also do quite nicely is we call it mobile maintenance. I mean, the core skills of maintenance remain the same. However, we have a lot of technical tools well in place so that we can have the documentation ready. We can order spare parts on the tablet. Spare parts with the next milk run are automatically coming onto the machine. People do not need to go back to office and start a computer to order the spare parts. So here we have really increased a good amount of our overall machinery effectiveness. What we have also done is, and then on the left-hand side, you see a picture of one of our fully automated assembly lines. Here we have also invested a lot of time to come up with a proper solution. We have removed the SCADA level, which is then removing a lot of complexity. However, let me go back one slide to show you once again this automated assembly line. It looks quite homogeneous. There are 7 manufacturing cells, but they are all coming from 7 different suppliers. So this was willingly our decision to go for individual suppliers in order to force them to talk to each other, to really integrate all different kind of special solutions into one manufacturing line. Yes, a lot of hurdles had to be overcome. A lot of complexity had to be overcome. We also had to force, of course, those companies to open up their source codes in order to implement those machinery. But this is actually Industry 4.0. Integration of various vendors, integration of various applications into one, and then, of course, everything under the umbrella of the MES system. Here are some other impressions. I will not go into further details as the slides are also to be shared after the session. Respectively, you can review the live recording of the session. What we also do is we are currently testing out several cloud applications, whether it's here an example, Microsoft Azure Cloud. We are also using Siemens tools. We are using Google tools whatsoever. In order to come up with maybe just then in the future one solution in order to reduce the IT complexity, but yet we are not able to really tell you which kind of tools, which cloud-based operation makes more sense in which kind of area of production. So this is still an ongoing process. Yes, also we are collecting big data, but the big question is, of course, how do we analyze the big data and how do we make use in the most efficient and effective way? Here are some further ideas what we do. I mean, scrap rate, we are analyzing, for example, outlier analysis, setup times. We do other analysis of production in order to really increase productivity, decrease downtime. And what I mentioned also in the beginnings, we are also working heavily on our energy consumption. And I think this is one of the major wins. And this is how reducing the energy consumption tremendously. In some applications, more than 50%. And I think this is cost saving. And this may be a complete different part of another presentation for some time. Very important is also collaboration. I mean, whenever Industry 4.0 implementation takes place, obviously we need all departments involved. We not only need IT or manufacturing, we also need human resource. We also need, of course, product development in order to really join this change in terms of implementation of Industry 4.0. As I mentioned in the beginning, of course, without training people further, the implementation of Industry 4.0 may not work at all. And here is actually, yes, a nice picture, which I really love. It's literally from screwdriver to artificial intelligence using augmented reality tools also in maintenance. And from a technical point of view, this was never ever a real problem to implement. The biggest hurdle that we had to overcome was to train people in their last working decade, 55 years plus. Germany retirement age is 65, 67 at the moment. And our biggest hurdle was, and frankly speaking also underestimated, is to train the elderly people to use modern technical tools in their known environment. Elderly people are excellent in terms of experience on the machines, and the young people really appreciate to learn from them. Vice versa, we are now, of course, using younger people to help the elderly workforce to use IT tools in a more efficient way. So what we have done is also the central part of our plant in Germany, we call it a Scharnhausen plant, is really a learning factory. What we learn here is really one-to-one available on the shop floor, so people can directly be trained on the real processes. On one aspect, of course, we train people on MES. We also, I mentioned Microsoft Azure Cloud. Here we do traceability. Mobile maintenance is a big topic, energy data management, overall equipment effectiveness. There are 50, 60 more courses that we do. Important is that it's a real cyber-physical training environment. It's a real hands-on training environment in order to develop the skills and the experience and the knowledge of the employees. And now, of course, based on our experience, we are also offering those courses externally. For this reason, our best practice example is also our CDTI center in Singapore. It's a competence center for digitalization technology and innovation. This has been jointly set up by the Technical University of Munich in Asia with the support of EDB. And yeah, please contact me. Please feel free if you want to have a tour, if you want to come and see what we are offering. There's a huge range of Industry 4.0 related technology courses. Very soon we are coming up with more energy related courses. and also topics related to IT, like cybersecurity, connectivity, implementation, etc. So that's the short overview from my side.
So let me start. We talk a lot about Industry 4.0, but nobody talks what was Industry 3.0. So Industry 3.0, mainly all the development taken place in the material sciences like nanotechnology and all these kind of things, right? So more emphasis was on material science and materials basically. Now the Industry 4.0, the main emphasis is basically Internet of the Things, like artificial intelligence, automation, advanced automation, machine learning, and the big data. So how do we use these technologies for the development, the growth, and the better efficient management of these sectors? In energy sector, if you say, the artificial intelligence and robots are finding a lot of applications in the oil and gas sectors, power generation, renewables, storage, nuclear waste, and energy consumption, etc. So AI-enabled robots are very useful in the, let's say, when you do the maintenance of the basically inspection, repair, and maintenance of the offshore installations in the oil and gas sectors. Some of the things which was very difficult for the manual maintenance are being done by the robots very efficiently nowadays. We have moved basically from the condition-based maintenance to the basically reactive response maintenance and interactive more. It is more rather predictive failure management, which we are now at the moment the sector is pursuing basically. So we have come a long way, and for this you need to analyze a very big data, which is not possible by the, let's say, manually or by the human beings. So we need some kind of large, very powerful softwares to analyze all this data and predict the failures of the equipment and the machines. Then a similar thing happening in the wind farms and the solar parks. It's especially offshore wind farms. Now the maintenance being done by the drone-based robots, which go there and then maintain or repair the wind farms basically in a much more efficient way, and in a it's much more safer to do these operations in the renewable sectors. Another thing is that this is a huge, massive data is coming out of this. You take off generation, you take off transmission, you take off distribution, or you take off any oil and gas pipelines, maintenance, flow, etc. All this needs a very, very huge data, and millions, billions, or petaterabytes are coming. So you need some nice and very powerful software to analyze this. And it's not only data analyzing, but give the prescription out of this analysis, which the human being was difficult to analyze all this kind of data. So this is the very useful tools, and the softwares are being developed based on this, and that is what we call this new automation is taking place in the sector. And then we are reducing the risk also. There has to be a lot of risk when we do this, deep sea installations, deep sea maintenance of the pipelines, seabed pipelines. It was very, very difficult, and lot of safety of the manpower was at risk. Now it's being done all by robots. So we improve the safety of the people, and we improve the safety of our installations, then improving the health and also the safety of the equipment, because you can predict the failure in advance. I give an example. There was an accident in India in a power plant where basically the boiler pipe just choked and burst, and it was a major accident. So had it been in this present time, it could have been analyzed in advance, and there had been indication that this may fail. So this could be taken a preventive maintenance on that. Yeah. So this another thing is that in oil and gas sector especially, the biggest investment comes by the company, how to really locate the reserves, where are the oil and gas are really there. So it used to be a very cumbersome, very expensive, capital intensive process. But with the modern, let's say with the artificial intelligence, we can in a much better way predict where the reserves are based on the certain sensor signals and basically geoscience and geo investigation and their better analysis through these softwares. So this is getting much better. The predictability is getting much better, and the probability of finding the reserves are all there. Then another area which is in energy sector, I'll say the virtual plants. as you may be all aware, that now the generation is coming from multiple sources. We have renewables, which are intermittent. We have our conventional coal-based generation, thermal generation, for example, we have hydro generations, we have another gas-based plants. So this multiple kind of generation, when they have to be integrated, it is a very cumbersome task. So it's not possible rather manually. And now what we call them the virtual plants, where we can dispatch as per the demand, what the customers, how the consumer behavior there. And these all data can be analyzed and integrated through artificial intelligence. One more advantage of this, that you can control all these plants sitting at one place, what we call the sort of regional control centers. And this is the, let's say, order of the day. You will find more and more distributed generations, and the trend is in that. The more renewables you will be adding it, more diversified it will be. So this really is helping the industry, which would have not been possible, let's say, 20 or 25 years ago. Then another thing is the operation of the transmission network or the grids, transmission grids. It is very important issue because the grids are getting more sophisticated with the, let's say, with the development of microgrids, mini grids, and then smart grids. In the smart grids, you have multiple source of generations and you have multiple distribution centers. So how to control that? How to make a dispatch which is suitable for the customer demand, and you do not generate unnecessarily, or you have the right generation mix. Suppose the customer is willing to pay for the renewables, I must be able to supply them the renewables. So this is one aspect, how you integrate and how to analyze and how to do the forecasting and planning and efficiently maintain the grids. Another very important aspect with this advent of this technology, it's not, I mean, I would say nothing come without any risk. So there is always a risk, and the cyber security is very, very important aspect. We are implementing all kind of technologies which are available in the industry 4.0, that is artificial intelligence, machine learning, data analysis, all this, but at the same time very, very prone to the cyber attacks. And the grid, the national grids or the transmission network, always related to the national security also. So we have to be very, very careful to adopt all these technologies and make the data protection and the cyber security also give them the paramount importance, so that we are not hacked and our networks are not, being targeted during the by some bad elements, I would say. And of course, the terrorism, all these kind of things are happening all over the world. Then another very important, I would say, use of these technologies in the basically power trading or the electricity trading. Now you can trade the electricity even by the algorithm trading. So they will find out what are the best source of that kind of point of time to supply the energy or to supply electricity, and what the consumer demand is there. What is the consumer behavior? These behavior patterns in a geography, in households, in everything, you can really now analyze by putting all the data together and sourcing these data also properly. So this is very important thing. Before it used to be, one regional control center or the national or dispatch center, they will tell you what time you can get what, and irrespective of the demand. So it was a very inefficient operations, I would say, to that extent from the consumer points of view. So this is another very important aspect where you can use these technology, and these are being used also. We have, I mean, in Siemens, they have this active network management tools, or this, I would say, the program software, which is managing complicated integrated grids. And this is a very useful tool, I would say, or very useful software program. Then there are certain implications, as Volker rightly said, that all these technologies are very good. They look very efficient, very profitable, and I would say they save a lot of energy, they save a lot of, create a lot of efficiency in the system, but at the same time, we have these implications. I would foresee in the down the line 10 years, it would be very difficult for the conventional works to go on. The low skill jobs will be phased out, and to do all this and to use this technology, we need high skilled workforce. So that's a big challenge. I was reading one report at a given point of time. Now we do not have more than 10,000 people who are really trained in the artificial intelligence, all this kind of using these for the industry purpose. So this is a big challenge for the utilities, for the people, for the companies, and I would say as a nation as a whole, how to skill our people. and to skill the old workforce is equally difficult, and you cannot take them all off at the same time. They have the technical expertise, but at the same time their skills are outdated in the sense with the present era of the technology. So this is the biggest implication of these industrial 4.0 on the human resources in the company, in the utilities, or in the country. Then at the same time, it gives us a time, if we have the right people, then on the management side, you can have a lot of I would say you can practice a lot of emotional intelligence, how to employ that workforce. You can learn a lot of people leadership and the verification of the insights. Any software or any technology, at the end of the day, it is the human which will finally verify. So verification and insights of these outputs also, you will have time then to analyze this and to confirm or to approve all these things, right? Then, as I said, that challenges for the data protection, the cyber security, these are the biggest challenges. These are not only in energy sector, is very prominent, paramount for the national security also. I mean, imagine a situation if your grid is hacked and complete lockdown, shutdown takes place in the country, there is no power available, what will be happening? So just imagine a scenario. So these are very important aspect of this, that you implement these technologies fine, but at the same time you have to take care of the cyber security and the cyber attacks or the data protection. This is very important. Another, which is a little side effect, I won't say it's a big drawback, but that all these AI data centers, they consume a lot of power also. So these are not the, I would say, very small expenses. Sometimes it can lead to major expenses, so they consume a lot of energy. So what we need today is more, I would say, energy neutral data centers, so that and more efficient one. So whatever gain we get in the, let's say, reduction in the energy demand or the losses or all these kind of things, that they are compensated for. So these are the primarily, I would say, in energy sector, they are across the board. There are applications, especially with the more progress in the renewable energy sector. These technologies are getting much more important. I mean, you have now the drones and robots which can string in the transmission lines. They are maintaining the transmission lines. So all these kind of things which was not conceived of before, they are much more. You can go to any remote area and you now construct the transmission distribution lines or distribution networks. So this is the really great advantage of these technologies, and I conceive, and I'm, let's say, fully convinced on that these will be much more application of these technology in terms of automation, in terms of maintenance and operations of the energy sector as a whole. I would also like to touch briefly on the water sector. Actually, these technologies are not still in, I would say, water sector is maybe 10-15 years behind the energy sector, but still a lot of work is going on, and we are using these technologies, for example, in the smart water management systems, which are mainly based on the advanced softwares nowadays. Then maintenance of the water distribution network. One factor is there in this sector is the most of these installations, even in the developed countries, are quite old. So to gear them, to put the lot of sensors and all this kind of them, and then get the data, analyze it, and then put the right efficient, I would say, forecasting and planning and maintain the distribution network is a big challenge, basically. But these technologies are very, very useful, especially for the maintenance of the distribution network. You should know where your leakage is, how it is going to be, what are the patterns, how the water is being used by the consumers. All these kind of things you can analyze through these technologies now. And then the operation maintenance of plant. It's a very one unique thing is in water plants or treatment plants is that the raw water quality keeps on varying. I mean, the turbidity of, if you have a desalination plant, it can go bloody from anywhere 30, 40, 50 up to in thousands, basically. So this is a big challenge. And if you analyze on like an analog system or without the, I would say, very high speed data, it's very difficult to optimize the operation of the plant. But with this, Hitachi developed a system basically where they are in the desalination, and they reduce a lot. They reduce the water waste. They reduce the lot of energy consumptions and the chemical consumption also accordingly. So these technologies are very, very, I would say, useful and efficient for even for the operation and maintenance of the water treatment or wastewater treatment plants. Then we have now coming with a lot of intelligent control. Now we can control the plant sitting in a remote location or somewhere else. The whole plant can be controlled now with the putting the right sensors, creating the, acquiring the right data, and on a continuous basis, in a real-time basis, and then we can, or more efficiently, we can optimize our processes based on these data. And as I said, the raw water quality can be monitored, and accordingly the actions can be even given by the system itself. So that is where we are now increasing use in the asset, basically asset monitoring and the proactive management. I say the fed is from basically, we used to be reactive. There is something has gone wrong, the fault has taken place, then you have to repair it or reactivate. Now it's more on we are on the proactive and the predictive mode, that we can, before the fault really occurs or before the equipment failure really occurs, we can find out and we can make a prediction, okay, this needs to be changed, so that there is a continuous efficient operations of the plant. And then another thing, these advanced software, so they can be used in the infrastructure planning, because this is very haphazard planning takes place, especially in water sector, that you keep on adding little pipes here and there. So on a comprehensive basis, we want to do the infrastructure planning, then these tools and these technologies are very useful. And some of the, in some, I would say, complicated environment, the robots, etc., can be used for the maintenance of the equipment and the plants. From my side, this is all what we can say. But one thing I can say, that the use of these technologies in the energy sector will go in a big way. They are being used on a very high scale, but still they will be used. But the fundamental thing is, we need to produce the people, we need to train the people so that they can use these technologies efficiently and more on a collaborative basis. Because nowadays you just cannot sit on one thing and that I have one thing and I can efficiently do all the operations. You need to have two collaborations with it among different things and different modules. What Volker was also telling, that these are different subsystems, and then you have to integrate it, and to integration of these subsystems is very, very important for any sector, and especially in energy sectors. So thank you very much again for giving me time this, and I hope something can be useful to you.
Now we're opening up the session for the panel discussion. And while I do have my own question, as I said earlier, primarily in the topic of three areas, if I can say. One is on the cybersecurity and privacy part of it. Then second was on the skill part of it, and third is the brownfield and greenfield issue. So I'll come back to this question. So let me give an opportunity to the audience first to ask the question.
Thanks for giving me this opportunity. Now, manufacturing is one of the focus area for us. Both from IoT AI perspective, we have created a significant ecosystem of solution providers. But the way we look at it, and that will lead to my question also, we look at it, manufacturing transformation in three pillars. One is process excellence, applying Lean Six Sigma and continuous improvement. Second is operational intelligent operations, which can be driven through CRM plus ERP integration, a fabric of information flow across organization. You can use Microsoft Dynamics and a bit of automation using robotic process automation. And then the third one is what we are talking about, IoT AI for smart manufacturing. I personally believe that first two are very critical before we go to the third one or along with the third one. What is your view, Walker, on this? And before you go to your answer, second question is, Mark talked about in a distributed manufacturing, cloud is a challenge. The way we address it is by recommending an edge configuration. So you deploy in a distributed architecture all the applications on the edge, so that it doesn't have to go in the cloud per se, but then in a multiple factory distributed environment, time sensitive information or decision making is done at the edge. But still, in a non-time sensitive manner, you can aggregate everything in the cloud so that management can have a unified view. Now, do you look at it the same way, or do you look at it differently?
Volker, would you like to go first, or would you like me to go first?
You can go ahead, Mark. That is fully fine with me.
No problem. So thank you, Shekhar, for the question. When I look at the distributed model, it's more from a perspective of the various applications and solutions that will be delivered will have various needs. There will be solutions that will be delivered that needs to take the benefit of cloud, whether that is providing centralized overview of the processes of manufacturing, so that, as you say, management can avail of a centralized view or dashboard of all operations. But there will also be then applications, if I take an example from the oil and gas world, where a lot of the drilling data is very private and very sensitive. So from a security perspective, they prefer to keep a lot of that information within their on-premise data centers. And then when you get to where you want to have fast decision making being made at the edge of operations, where you actually need to do the compute at the edge of operations. So the solution and the applications themselves will have different needs. Yes. From a software development perspective and delivering those solutions, the software industry itself has to acknowledge that not every application can just be delivered from cloud. It has to be, the various applications have to take in the reality of what industry is asking for, and having the option of either running at the edge, running on premise, or running in cloud.
Yeah, so that is one of the things we do. We have an edge computing partner, European company, and that is precisely we do. How do we deploy software applications at the edge, and some part of it is to be aggregated at the cloud level. It can be done so, or applications at the edge to be updated or modified or added. That can be done from the cloud at multiple edge locations.
Yes, exactly. So the whole way that cloud native is developed nowadays, and without getting too technical, there's a very big push into the world of what's known as containers and Kubernetes.
Exactly.
This development approach makes it very, very flexible. But for the software industry, for them to take advantage of it, they need to be agnostic of where they're delivering to. And that is specifically one of the areas we at Biqmind do work in, because of that distributed model, and acknowledge that it has to really accept that there is a distributed, it can't just purely be cloud.
Oh, fully agree. I mean, what you mentioned is the basis, I mean, for Industry 4.0 is definitely lean. Without lean, Industry 4.0 is not possible. And then on the other hand side, I mean, I can only confirm what you mentioned. What I did not cover in my presentation, however, is also something which companies also need to understand, that digitalization for all aspects does also not make sense. I mean, digitalize wherever it's possible, digitalize wherever you can implement it, but not necessarily, I mean, for a lot of companies, it doesn't necessarily mean it has to start on the shop floor, because digitalization on the shop floor is the most expensive part. I mean, you can also start with digitalization in terms of customer connectivity, in terms of, I mean, now we can also use a catchword called supply chain 4.0. So this is in line what you mentioned, and fully confirmed.
It is evolutionary, right? It is not that overnight we can rock the boat and do everything digital. It has to evolve.
Correct. Well, so I think Industry 4.0 certainly is a long journey. And it is a journey, right? It's not an end goal that, as you said, we start something and tomorrow will be Industry 4.0 ready. It's pretty much a journey. And I think this way, I think more specific discussion about use case level, what is the definition of Industry 4.0 for a customer A versus customer B, and then we work towards it, and then we continue to evolve, as you said. So I think
I mean, maybe CK, maybe I can quickly add something here. I mean, what we normally differentiate is we differentiate between the larger companies. They most likely already have a functional Industry 4.0 implementation. We can rather learn from them. The big challenge for us at the moment is how do we help small and medium-sized enterprise to not get disconnected.
Absolutely.
The small and medium-sized companies, if we look to Singapore, you have something like 250 small manufacturing companies. The Australian landscape is quite similar. A lot of small and medium-sized companies up to maybe 30, 40, 50 employees.
Yep.
And this is the challenge at the moment, not the big players. I mean, I'm sitting here in Thailand. We have a lot of Japanese manufacturers here. We can learn from them. Yeah?
Yep.
But the challenge is to really support small and medium-sized companies to define, first of all, the right business model. And this already is a challenge for them. What is my business model of the future? And then based on this, we can define the transformation roadmap. Singapore has a nice index called SIRI, but there are other index that we can apply. And then the biggest question is, after understanding the concept, after developing the business of the future, then the question is, how do I start to implement it? And this needs to be an individual approach. It's not a general approach at all. And last but not least, I mean, to be frank, at the moment, we don't have experts in the market.
Yeah.
You have wonderful solutions, large solutions, whether it's Siemens MindSphere, whether it's Oracle, whether it's SAP, but also here, I mean, an overall concept is not yet easy to be implemented because none of those companies, there's no experts in the market. When I look at our competence, I mean, when I look at our factory, I would need 50 people maybe from us to put together to come up with one expert having all the overall knowledge and experience. Yeah.
It's just a general question. So I'm just a recent master's graduate in mechanical engineering, and it's like the industry 4.0 is a convergence of operational technology and information technology. I'm good at the mechanical concepts, but when it comes to the IT concepts, I'm actually at confusing. It's always a confusing thing. Even if I try to understand it, it's just a overview of it. I can't just go and after a level, I can't go about it. So what should I do, or how should I approach it so that I get at least a grasp of the concept?
I think it's a very relevant question. So I'm not sure who would like to answer this. Maybe Anil or Volker, you could add here, because this is always a challenge. And I agree with Veerapan that one can't learn everything, but at the same time, he or she need to have certain understanding of where the IT and OT meets. So who would like to help Veerapan to address his questions?
I would suggest Volker can address it properly because he has the challenges of the workforce training. At the same time, you know, how the operational technologies can be integrated with the IT technology. And I just want to say one general comment in that sense. People say the small, medium enterprises in any economy, 60 to 70% output come from the small and medium scale industries. The large industries are just in the top 20 to 30% contribution. Even German economy also 72% contributions come from the small and medium-sized enterprise. Okay, so I would say the biggest problem what the industry is facing at the moment is not only that as Volker said it rightly, yes, we do not have the right trainers or the right experts, also not in adequate numbers, but at the same time we do not have the rightly educated workforce. So it's a two-way problem. Once you intake is poor, at the same time we do not have the enough experts in that, right? So maybe Volker can go on.
Okay, well, thank you so very much, Veerapan. The same question you posted in the chat. Also, thank you for this. I can't give a short answer on this. I mean, as I also mentioned in my presentation, the big question is always: is it an environment is to be established newly? Then it might be easier in terms of the IT concept. Because then you can also then use modern tools to first of all simulate even a complete plant. This is what's happened nowadays. I mean, we also try it. We complete our latest production facility. We simulate first. We connect it with the real MES system, and only when it works properly, then when the processes work, then we start building up the facility. And this is what other companies do as well. The bigger challenge is if there's an existing IT environment and you really need to overcome the concept, there is no easy answer for this. The first question is it a standalone solution? Is it to be an integrated solution? Then again, how much budget is available? How much budget companies want to spend? Because of course you can always go for the large solution. that may not be a solution. So unfortunately, I can't give a straight answer for this. It's always a case-to-case decision. What is the current environment? What do we want to achieve? Important is always, what do I want to achieve? I mean, people just say, yeah, I want to get the data. Yeah, but what are you doing with this data?
Okay.
How do you analyze the data? Are you then improving your process because you know certain production variables and values? I mean, that's as I said, it needs hours to answer this question. Sorry about that, but you got my email already?
Yeah.
You got my email already? Drop me an email, and then I will get further information to you by email as well.
Maybe just quickly to add my comments on Veerappan, because I do kind of get connected with the institutions where I take lectures for the young professionals like yourself, and I could also relate myself when I graduated. My bachelor degree was in electrical engineering, then I did my master's into robotics, and frankly, I'm still learning every day. So first of all, IoT is way more complex than these three letters. At the same time, depend on what role you want to play in this whole IoT ecosystem. Whether you want to be an expert in mechanical design, whether you want to be expert in AI analytics, or what I would say, which is the missing gap in terms of the skills, if I would say from my experience, is we are missing a lot of architects who can connect the dots. So who are not deep dive, who will write the code on Raspberry Pi, but somebody who understands what it takes to connect the sensor to gateway to the infrastructure and everything. So that's one skill which is hugely missing in this whole IoT ecosystem. At the same time, these architects are not just pure technical architects; they have to be more business and use case architect. And this is where comes the domain knowledge also, right? So obviously it will take some time for you to get there, but at the same time, how you could accelerate, in my view, is one is a session like this, which we are hosting. Second is do speak to more domain experts, like get connected with people like Volker, Anil, Mark, and many more out there who are, I'm sure, will be happy to give you some advice that how do we go about it. But at the same time, like I said, you have to think yourself that that you want to be deep on the technology aspect of the piece or a broader picture of the architecture point of view. So my best wishes to you, to your future career. For OEE dashboard, other than the manufacturing line OEE as a whole, do you have the dashboard for the machine level OEE as well? If yes, how have you integrated this machine to capture OEE data point in the real-time basis? It's a little technical question, so I'm not sure if you would like to answer, Volker, now.
Well, thank you first of all for this question. I think Mark can also answer part of this. From our part, what you have seen also in the presentation, I mean, the tools we are using, also cloud applications, none of them are yet real time. Therefore, in our environment at the moment, we do real time, yes, but not for the OEE and not for the data analysis. Likewise, in other companies, I mean, also our shop floor is not real time connected to our MES system. I mean, normally the replica is done twice a day, in some areas 4 times a day, but that's the maximum at the moment. And I think all the experts may agree that this is still the prevailing case for a lot of companies, that I don't say that the shop floor is digitally disconnected, but as I said, I mean, the volume of data is so huge that the replica is only periodically, and therefore no, our applications are not real time. Safety applications are real time. Also, I'm sure Mark can add, but yes, as I said, I mean, the real time data is not put into the cloud and not into the OEE dashboards.
Correct. Yep.
So, I mean, in regards to the real-time perspective and the volume of data, I mean, this is some of the areas that are a challenge, is how much of, because of the large volume, how much of that data can actually be processed in real time at the edge of operations to make the decision, and the remainder of it then, whether it's periodically or sometime afterwards, pushed towards centralization for review and later use. So this is part of the difficulty, is to decide which is the most useful real-time data to actually use, and if it is real-time, can it be processed where it's needed in the operation? And when I say edge, I don't specifically mean right at the very end of the chain. I mean anywhere along the process. Can it be utilized at that time to assist and improve the operation or the process that it's being collected for? So real-time data, certainly when it comes to automation and safety, there are very specific software and technologies that are used for that, whether it's real-time operating systems or PLC controls, because those are very dedicated functions. There is a move now happening towards use more universal hardware to run these types of real-time systems, but it's only gradually at the moment. A lot of industry is still utilizing either digital twins or processing the data slightly after the fact.
Correct. So I think again it depends on the use case. What is real time is good enough real time we need in case to case basis. Something mission critical, obviously it have to be real time, but something we need to make decision. Then I think we can weigh in what kind of technical requirement we should keep in mind. What are the harsh environment where EMI is so severe that RF wireless communication would not be possible or banned? I think, as you know, signify from the Wi-Fi perspective. Basically, the question is,
from the harsh environment, just in regards to radio and wireless, obviously has a massive impact. We all use home Wi-Fi, and we know if we stand on one side of the room, we don't get it. We stand on one leg, and we get a better one. So the EMI harshness, especially when you're looking areas like the rail industry, have a very big problem with this. Whether it's the rolling stock or the depots, they have a problem with just the natural generation of EMI and then trying to use wireless in those environments. It's also in sort of large-scale manufacturing as well that happens, like shipbuilding and those type of areas. There can be a lot of EMI generated that causes a lot of problems with wireless. And we specifically have those problems even in the oil and gas industry. That we worked with Lantern Edge on was trying to look at how we overcome those. But there is quite a few different types of industries that generate EMI. In regards to the band part of it, radio frequencies are controlled country by country. Typically within the ISM band, the 2.4 or 5 gigahertz that we're all used to within Bluetooth and Wi-Fi, generally those are the unlicensed. But if you get into areas where you're using low RAD and so on, where some countries may need license for those. So when you're looking at wireless, yes, you have to take a lot of this into consideration. And wireless deployment of equipment and solutions can be a complex and tricky area to work in.
Yeah, thanks, Mark. And before we get to the next quick question, so Volker have to take a leave. So let's give a round of applause to Volker. Thanks, Volker, and we'll catch up again with you in the coming time.
Sure, wonderful. Thank you.
Volker looks much younger here on the screen rather than in his picture.
Maybe we should catch up Thailand Bangkok
yeah,
sometime.
we can catch up any moment. You just pass on my mobile to Volker, right? Very nice.
Thank you so much. Stay in touch. Thank you for attending. Bye.
Again, this is a usual challenge which many companies have when they're building up a greenfield project, building infrastructure, IoT readiness. What are the global standards or framework they should try to follow? Because many times when you talk about Industry 4.0, what works in Singapore may not work in Malaysia or Thailand. Maybe, Anil, you could help to guide along any references?
If you say putting an industry, it's not only, I would say there are many factors goes into it. How is the basically business environment in the country, right? How is the economy of the country? Once we did a study of the whole ASEAN, right? What are the competitive economies is there? But I think its question is more point of view from the, I would say, factory automation or how the, let's say, IoT things in the, when you start a new factory or I would just only a general comment that in terms of the readiness of the availability of the people, availability of the critical infrastructure, I think Thailand and Malaysia are on the same footing in terms of the IT infrastructure. Right? Probably you will have more, I would say, in terms of the linguistic ability, Malaysia could be better than Thailand, right? But at the same time, there is a much more disciplined workforce available in Thailand in that sense. So I think Mark can answer this question in terms of the, I would say, IT environment and how it can be, right? I can more answer on the strategy or on the economy side. Okay.
I mean, from a standard perspective, I mean, it's not that IT is unregulated and digital systems are unregulated, but there's very little in regards to from a IT perspective in sort of saying this is the global standard or this is the global certification. In the hardware side that I was talking about, yes, there are approvals and regulations and certification for certain equipment to work in certain environments. But for the IT systems themselves, there are a number of standards that you can that come from the IT industry about how the system should be deployed, how it should be operated. There are also a number of security standards to ensure when we're looking at cybersecurity and so on that can be then you have to be matched against to ensure that if it's an IoT system you're going out, and this is one very big key area. Which I think, CK, you're covering in your next session, is looking at cybersecurity around IoT. Those type of standards do need to be improved, to be honest, and do need to be pushed out. But from a testing perspective, like we do with electronics and hardware, there's probably no official standards that say you have to meet or you have to be at this level. It's more driven by the business itself.
But one thing, Mark, which I foresee in the future, these all standards will be basically conformed across ASEAN, right? They're going to come on a common standard, you know, later or sooner, it has to conform to the same standards, right? Whatever they adopt.
Yeah, I mean, various country standards, again, coming to the hardware side, various country standards do sort of confirm. A lot of ASEAN have started to either utilize EN norms coming out of Europe, or some of the US norms, and specifically on the oil and gas and the hazardous side. I see the next question Alan is actually asking in regards to the ATEX requirements for that type of equipment. So there is a normalization of those standards, and the IT industry from a software perspective is trying to get to that point. But a lot of it is driven from the business need. On that side.
The session has been very engaging, and as we always mention that Industry 4.0 is a complex topic. We won't be able to cover in 90 minutes. So what we have been doing it, as you might notice, that we are trying to cover up different part of the solutions, whether it's cybersecurity, whether it's a communication technology, whether it's a architecture. At the same time, we're trying to cover up multiple industries also, so that we could kind of cross-pollinate the ideas and thought process that what may work maybe into oil and gas, could we also learn something into smart building. And just last quick summary, any call for action, any message you would like to give back to the participant? Anil, Mark, maybe we'll go with Mark first. Any message for the participants?
Just mainly to thank them obviously for attending. If they do have any questions, either reach out through yourself in the organization or reach out directly. I mean, you shared the LinkedIn details. So if there's any specific questions around some of the solution that we talked about, the landed edge for positioning, certainly do reach out. Happy to discuss it. In regards to the actual looking at Industry 4.0 going forward, I think the biggest thing is to look at what is the actual business need. What are you trying to solve? Look at the opportunity. Look at the problem. Don't look at the technology first. Don't look at technology and go, oh, I'll utilize this and it will make my life much easier. Look to see what the problem is that you want to resolve. Will it actually improve the business and the processes? And then say, okay, I know what my problem is. I know what I want to solve. now is there technology that can help me do that? So from my side, it's always about looking at the use case, looking at the business opportunity or the problem, and trying to then find technology that solves that problem.
Agree with you. And Anil, any message for the participants?
No, I would say only one message to the participants. Like Mark said, look at your resources. Industry 4.0. I mean, Thailand come out with the Thailand 4.0. And the economy and the development. Not every sector in the advanced stage. Different sector on different stages in this Industry 4.0 implementation. But there will be a definitely convergence of the, as we say, the information technology, Internet of Things, and the manufacturing or the operations, basically. So you need to look at your resources, what you want to do, in which sector you are, what should be your next step, and how you integrate the whole of the IoT in your systems or in your factories, and get the, I would say, the advice of the domain experts or the experts in this field. Like CK is there, he can integrate many things, right, for you. So that's there. When it comes to the any question related to ASEAN on the economic side, on the, I would say, on the business strategy, etc., you can drop in an email and we'll be more than happy to answer you on that. Okay.
Thank you both. And just again from my side as a wrapping remark, All Things Connected, as the name says, the company we run, also the name is, we fundamentally believe that things, humans, systems are going to get connected. Whatever technology we speak today, whether IoT, AI, brainwave communication, whatever comes in next 20 years, fundamentally things are going to get connected. But before we talk about technology, as Mark and Anil and even Volker mentioned, that technology is there for them out there. I personally talk to many startups doing innovative work as well as scale-up companies. But the problem is something.ai doesn't solve the problem. Right? So we do need to understand what the problem are we trying to solve. But the beauty and the challenge of this industry transformation is, or rather we read it reverse, transformation digital rather than digital transformation. The transformation is critical. What we are trying to transform as a company, which include not just putting some sensors in the machine, but transforming the people itself, where the capability comes in, what we Volker was talking about. So it's a challenging journey, but it can be done. It is not sprint, it is a bit more like a marathon. And we have to break it down our own Industry 4.0 journey from a use case perspective at the end of the day. Because as again, all of them speak about what is your journey, what is my journey, may be different by definition. But once we understand our journey, what we are trying to do from current state to future state roadmap, but again, as company, All Things Connected, we also address to map what we are today, what we want to do, and the same we help our customers and partner to get to the journey. So complex topic, but again, I enjoyed personally this session. So thanks Mark, Anil, and we'll share my regards to Volker again. We are already working with some of you. We hope to work with some of you in the participants. So look forward to engage again in the upcoming session. So thank you, everyone. Take care.
Thank you very much. Thanks.
Thank you.
Bye. Okay. See.